Curtis Galione is a Flink specialist in the so-called Advanced Technology Group at Confluent. That means he helps people who are actually trying to build things with Flink and Kafka make use of both technologies. I talked to him about the nexus of those two important pieces of infrastructure today. We covered a lot of ground, in fact, so much that this is going to be a two-part episode. So let's listen in now to part one. Hello and welcome to another episode of the Real-Time Analytics Podcast. I'm your host, Tim Berglund, and I'm joined today by Curtis Galione. Curtis is, I think it's fair to say, Flink expert in the Advanced Technology Group at Confluent. Is expert okay?
We can go with that. Yeah, for sure.
All right.
We'll say I'm an expert. I never like saying I'm an expert in anything because
I know it hurts. Right?
It's tough.
Flink specialist, Flink aficionado.
Yes, Flink guy.
Flink guy. That's very simple. That's a little less self-laudatory, I guess. So,
yes.
And that wasn't self-laudatory. That was my description of you. Anyway, hey, glad you're here.
Yeah, thank you. Thank you for having me. I appreciate it.
Yeah, let's start with just a really open question. Why is Flink important right now?
Sure. Yeah. So, I think part of it is that stream processing, firstly, is important, right? And I think you've had plenty of people on this show that have explained that. People that are more of experts, perhaps, than I am. Anna has been on the show. Anna McDonald, Robert Metzger has been on the show, right? So I don't have a whole lot more to say about why stream processing is important than probably they do. But I will add that I guess what is important is that what stream processing is doing fundamentally is sort of the same type of computation that people will be doing with a database, or people will be doing with an application, or some other computational framework. But it's doing it on a stream. And what's important about Flink, I think, is that there's a couple of different APIs, one of which is a SQL API that gives you the ability to do that without thinking about all the semantics, right? And so I think there are some really sort of nasty time semantics and different types of notions involved if you think about doing processing on like a changelog stream or something like that, or you have to think about doing like building an application on that type of thing, and it's complicated. And so if we can give you a way to not think about it in a complicated way and still get the power, that's sort of like the holy grail, right? Is give you the super powerful tool without the super complex knowledge that you might have to use it. I think Flink does a pretty good job of that, depending on which APIs you use. You can make it as complicated as you want, but in general, I think it does a pretty good job of allowing it to be an approachable type of framework.
Talk about, we have talked about the different APIs on the show before. That was, I think, Robert Metzger went through those. Now, that was great, but I don't know that we really we looked at it in quite those terms. So you're kind of talking about abstraction, right? You'd like to offer a high level of abstraction to people who need to do computation over streaming events. SQL's a good one, but that's there. What are the options?
Yeah, for sure. So I think, to your point, I think Robert did touch on this in his episode. But there's a data stream API in Flink. There's a table API, and there's a SQL API. I think I will talk a bit about the SQL API first, because I think that's sort of the most approachable for most people. When we think about having a SQL API, we want a SQL standard, right? I mean, there's a reason that like ANSI SQL exists. There's a reason that people talk about the SQL standard, or like, is this standard SQL, or is this whatever else type of SQL, right? And so to have the ability to say, yes, this is standard SQL, and it's actually just going to apply to this system over here, and it's going to apply to this system over here as well, right? I think Flink is, in some ways, changing how we think about whether or not you can write the same query that operates on streams versus operates on a table, because in Flink you can actually do that. Whereas, in other products, like you do have to think about specifically, am I operating on a stream right now? And that's also like kind of Kafka-esque language, right? So not Kafka-esque in a literary sense, but that's
In
It
the
is
data
Kafka.
infrastructure sense. Yeah.
Yes, in the data infrastructure sense, exactly. So, am I looking at a topic that's like append only, or am I looking at a table which is updating based on a key? You don't have to think as much about that question when you're using something like Flink. You do have to very explicitly think about that in something like Kafka Streams, for instance, or in KSQLDB. Um, and if you're familiar with those concepts and you're comfortable with the concepts, then that's totally fine. Um, but if you're not, then it can become a little bit hairy, right? Because you look at things and you say, well, yeah, I mean, I want to write this query, and the query exists today in Postgres, or the query exists today in MySQL, or some other analytical database, and you want to just port it over. And you can't really do that with a number of SQL syntaxes or streaming SQL syntaxes, and you can basically just do that in Flink's SQL syntax. So
Okay.
um, I think that's important, I would say in general. I haven't seen the upshot of it totally necessarily at this point, and I do work at Confluent, like you said. So we're hoping to see the upshot of it at some point, but I do think it's important regardless.
Right. I wonder um, if you don't mind me peeling that onion a little bit. That's unquestionably good, right? You want to offer a high level of abstraction that's familiar to the developers who, to whom you are appealing to use this data infrastructure to solve problems that they have. And so something like ANSI SQL, and don't worry about it if it's a stream, like we got you. There's no doubt that that's good, but the abstraction leaks, right? I mean, there's this. So as we record this, it's checks clock, April 4th. And Kafka Summit London was 2 weeks ago. I was there. It was great. And there was this announcement of this new Confluent thing called Tableflow, which is this stream, and we'll get to data lakes in a little bit. But it's another assertion of the stream table duality. And I want to say, and there's just no doubt that you win if you offer a simpler abstraction that requires the new developer to learn fewer new concepts. But how long does that last? Like, do you have to think about streams and tables? Do you have to start to wrap your mind around that?
We would say, I would say we at Confluent, and then also we just
Folks.
engineers or
Yeah.
technologically minded people who want this to work. We would say that we hope you don't have to always think about it, right?
Okay.
I think the goal overall would be, and maybe I will talk. I'll dive into a little bit of this. So the goal would be that you have in Kafka and Flink as a duo, you have that combination where you have unfettered access to your data in a way that you would not have in a traditional database, right? And so, to your point, the abstraction sort of breaks, right? When you think about the fact that if you're using Kafka as the storage layer underneath Flink as some computational layer,
Mm-hmm.
you do have access to Kafka still, right? We're not turning off access to Kafka at Confluent. I don't think anyone is turning off access to Kafka anywhere and just saying, oh, you guys just write to Flink, just do that. So you're always going to have this, in some ways, broken abstraction, right? Where you can write data directly to the log, or you can write data directly to the table, which is really underneath it a log, and the log is really a table also. And so like that duality is present in all of those places, right? And so you wouldn't give that type of access in a traditional database. You wouldn't have people just writing to log files on disk.
Yeah.
That feels very naughty. That feels very bad.
It would be broken
Yeah,
if
it wouldn't function the way it's supposed to function, right? Like
yeah.
if our credit card transactions were like somebody inserting a line into a log file instead of writing a transaction on a database, we'd have problems. We'd have very
Yeah.
big problems on
And
our
if you made a
hands.
database like that, it would be like a science fair project. You want to get on
Yes.
the front page of Hacker News because it's cool, not because
Yes.
that's useful. So yeah, you don't want that in the thing that we have received as a database, right? As a relational database.
Yes. And so what you need then is you need a way to interact with both of those things cleanly, I think. And I think that when you have something like Kafka and Flink put together, you get one and the other. as long as you don't look too hard at it. It's like when you say the same word too many times and it starts sounding weird.
Hmm.
Like don't don't think too hard about the fact that you can write things directly into the log and you also have tables. Just consider that there are certain types of streams, I'll call them, or events, or like eventing type applications, where you will have to produce event by event. And maybe it doesn't perfectly equate to a row in a table, right? Maybe it truly is some blobby like event. And it's not really perfect for that table. That's great. You can write that to Kafka. Um, Maybe you pull it into Flink, maybe you don't, right? Maybe you're not doing the same type of computation on it. Maybe you're manipulating it with something that manipulates data in the Kafka world, but doesn't manipulate more tabular data in like a Flink SQL world, right?
Hmm.
But for those things that you do actually have some structure on, you can write those to Kafka as well, or you can write them to Flink directly, I guess, in open source world, right? And you can do that processing there too. So the abstraction is sort of like broken, but also nicely divided and separate in terms of the way that you're going to use it, right? Like
Okay.
you don't want to be using one for the other. You don't want to be using them both necessarily for all things.
Right. And I feel like I'm camping on this for too long. So just let me be the host, and I can ask these questions. But I just want to pick your brain on this. Is the recommended abstraction when I'm in Flink SQL land tables? Should I be thinking of tables the way I've always thought of them?
I think yes, right? So I
Okay.
think I would say yes. I think especially if you're in Flink SQL, especially, right? Because Flink SQL, I mean, look, SQL is SQL is SQL, except maybe somebody creates their own variety of it, and then it's like
And
unlimited.
everybody's got their own little extensions and little incompatibilities, but you
Yes,
can sit down and write SQL.
or maybe it's in a prior role at a prior company, I used to write Sparkle, so that was happening on triples and graph
Yes,
databases, right?
and
So
RDF stuff.
in
Right.
RDF,
Right.
yeah. So
Yeah.
so maybe it's not always actually SQL. Maybe sometimes it's Sparkle, but for the times that it is SQL, then we're talking about tables, right? And I think, I mean, I could go way back, like ancient history at this point, I guess, right, to the maybe the original the tech blog post that started it all at LinkedIn,
Hmm.
the fundamental abstraction that every programmer should know, that Jay Krebs wrote about the log, right? And
Yeah.
so you could say that it's a log. Um, the log is obviously a representation of a table, or you would say the table is a representation of the log, right? And
Yes.
so it gets a little philosophical, maybe a little bit of zealotry, depending on which camp you ask, or if there are camps at all. But so I think if you're operating with SQL, then fundamentally think about it like it's a table,
Okay.
and like the tool that you're using, if it's committed to that abstraction, or if it's committed to providing that sort of interface to you, will make that work for you. I think it should, right? So if you're operating on a table and all of a sudden you go, oh, that's weird, like looks like this thing thinks it's a log, and it's like, well, no, don't think of it that way. Think of it as this is a table and it happens to be append only, right? So if you're in table land and you're using SQL, then that's an append only table. It's not a log, it's not a topic, it's an append only table.
Okay.
If you're only working with Kafka and you don't have that SQL layer to use, or you have KSQLDB or something that has that extra sort of delineation between streams and tables, then maybe you go down that rabbit hole. But I think it's easier for a user if you don't have to, generally speaking.
Got it. Now, we haven't, to my recollection, done an episode on KSQLDB, and I think it seems like Flink is dominating the discussion in Confluent stream processing land, and KSQLDB is not, if that's a sufficiently delicate way to put it. In KSQLDB, the stream table distinction is explicit. Like it puts that out front and says these are two different things. They're two different kinds of queries. You can make one into the other in all cases, and it kind of makes you wrap your mind around that duality. And I remember when I first read a blog post or whatever it is, or saw a presentation and that stream table duality, when this was 7 years ago, it was hard. It was like not easy to think through. It seems trivial now, but only because I've been thinking about it for a long time. It's not easy. So ksqldb puts that in front of you for good or for ill. And I think you're making the case that it would be nice to not hit people with that. Another thing that ksqldb and Kafka Streams both do, I think, is they're both pretty open about the Kafka abstraction leaking. What's your key? What are you partitioning by? You better know that, and it better be the right thing, because that's how you're going to be able to query a state store. So the notion of Kafka as storage is central to your life there. How does that work out in Flink? There's Kafka partitioning. How much do I need to know?
Yeah, so Flink is going to care about Kafka partitioning only in as much as maybe if you're hitting like a per partition throughput type limit when reading into Flink or writing out of Flink, right? So
Okay.
it's fun for us Kafka people, or I guess that you are now also a Pinot person.
Yeah, some of both.
But for the Kafka aficionados and the diehards, syncs and sources have always been a thing that exists within Kafka Connect, right? Like if you say, "Oh, what's a sync?" or like, "What's a source for this data stream?" or something, and you're talking to a person who knows Kafka, they are always thinking of Kafka in the middle, and the syncs and the sources sort of on the left and right of that,
as the
or
non-Kafka things.
non-Kafka thing. Yeah, exactly. So for Flink, what's kind of funny is you turn that on its head, and Kafka's now the non-Flink thing, right? So Flink is having a Kafka source, or it's having a Kafka sync, right? And so in so much as you have to load data from Kafka, I'll say load very abstractly, load data from Kafka into Flink, then Flink cares about the partitioning in terms of like how fast can I get that data from you. But once it's in Flink, it doesn't really care how you partitioned it in Kafka particularly, and it has its own sort of constructs for these things. It has things like key groups, and you can sort of do your own partitioning. I don't actually know that it's called a partition exactly in Flink. I think there are a couple different terms, but the basic idea is that you can parallelize the job or the work in the same way that partitions are acting as that parallelization mechanism in a Kafka topic. You can parallelize that work in Flink, but Flink is going to sometimes figure out, and sometimes you're going to tell it that you need a lot more or a lot less than whatever was in your Kafka topic. Generally, the fun scenario is that you need more, and you don't have to change your topic in order to get that, right? Which is not entirely the case for Kafka-dependent stream processing frameworks, right? Where like every intermediate thing you're doing in a processor topology is actually directly a Kafka topic. If that isn't the case, well, I should say and finish that thought, and therefore you do have to worry about the partitions on those topics in intermediate steps.
Unless it is willing to do that for you automatically.
Yeah, unless you have something that does that, which I don't know, maybe our friends at Responsive will do something like that, or maybe they already have with Kafka Streams, so that it just scales it for you. If you don't have to care about partitions, then you're more like in this Flink world where it's going to say, all right, that's fine. You had this many partitions coming in, and you have that many going out, but I'm my own person. Like I'm my own world here, and
Right.
so I will scale this how I see fit. Right.
There you go.
The squirrel does what it wants. It doesn't listen.
I still don't know much about that state store. So there's a Kafka source. Flink is consuming messages from Kafka, and it puts them into an internal state store because there are stateful operations happening, or what? What you're sort of hinting at that. Maybe tell me more about that.
Yeah. So there are things called state backends. In Flink, it's called a state backend. So um, I don't want to go too deep on them, but let's say the most commonly used one is like Rocks,
Yeah,
RocksDB.
as one does.
Yes, as one does, exactly. Same type of thing there, right? So you're going to have like these SST files in there somewhere. Um, they're going to be storing whatever the statefulness is of a particular query. And when we say state, I think it's also important to recognize that like you can write a query that is very high throughput that does not maintain state, right? So, or you can write a job that does not maintain a lot of state. If you're just doing like on the fly transformations, you could do gigabyte per second and have no state because all you do is apply a transformation, once on one particular field, and then you just
Certainly.
schlep it out the back end. So
Right.
that's totally fine. You don't really have to go too crazy in terms of a state store there, but basically, yeah, Flink is going to be materializing some intermediate result in this job in rocks as some table, as some key value pair or some
Okay.
table.
But that's not exposed externally. I can't query that table,
No,
right?
no.
Okay.
So yeah, the idea there is that Flink is using that. It's checkpointing those things or save pointing those things. We could get into all of that, but probably that's a whole episode by itself.
That's a whole
let's
episode.
not.
We dare not. We dare not.
So we won't go down that path, but Flink is keeping track for you. So Flink will keep track of what does it have in state that's intermediate, right? And if it has finished processing something, then it's already written it to whatever it's written it, right?
This to the sink. It's back to a topic because that's the whole idea is events in computation, events out.
Yes. So the checkpointing is happening. I mean, that state store is truly ephemeral. The checkpoint is only happening for that ephemeral state. As soon as the job is done, that is gone. That's not sitting around like materialized, waiting for someone to query it or hoping to be seen again. It's just like, hey, here I am. I'm helping you process things. Oh, we're good. I'm done. Like that's it. And it's
there
gone.
you go. Yeah. Okay. It's and this is, I think, more a rumination than a question.
Sure.
But it strikes me that I know that's a hard problem to say, no, actually we're going to keep the whole thing around and make it queryable in lots of arbitrary ways. I mean, you're a database then. I mean, that's the one way to optimize for that problem is you become Pinot, Apache Pinot, if you're thinking about the analytic ends of things. But the more on kind of the OLAP sense of like, what's the current state of this evolving entity? I've got orders coming in a stream processor and I have to do some things to them. And I want to know what my order ID 24601, give me that JSON serialization of that thing. I've just been wondering, like, why has Flink not gone there? Is that it's so outside its mission? Definitely hard, but there's a contained version of that seems like you could just crush some use cases.
Yeah, I think it's an interesting point, and it's a good question.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.